Welcome to the lair of the Batty Boffin.
Hi there Batty fans, a little more electricity with the Batty Boffin. Here we're looking at parallel circuits and how to calculate the resistance in them. If you're not familiar with using Ohm's law, V equals I times R, if you're not familiar with that, then pop back and look at some of the earlier videos where we do some calculations, because we're going to do some quite hairy ones here. We're going to do the most complex one that you've got, which is calculating combined resistance in parallel circuits. Now, a little bit of revision here. We have two types of ways of wiring up circuits. We have series and we have parallel. And I'd like to see if you can remember how the voltage, the amps and the resistance combine. So, under series, the total voltage is made from the volts in the first layer plus the volts in if you had them going in series, so your first resistor and your second resistor, you'd have your volts over the first component plus your volts over the second component to make the total. Okay? For the amps, the total amps are the same all the way round. The amps are the same all the way round. And the resistances, if you have some resistances, then the total resistance is just the first resistance plus the second resistance. Okay? We looked at those in one of the earlier videos where we looked at these formulas here. So in a series, when things are wired in series, the volts add up and the amps are the same all the way through. They're different in parallel. Could you fill in something like that here, please? If you don't know what they are, don't worry about them because I'm going to do them just after. But pause the video and have a go at that now, please. In a parallel circuit, instead of the volts being shared out, the volts are the same all the way through. And the amps are shared out. Resistance is a tricky one. Resistance in a parallel one, it's very like the series, except they're all fractions. And that's what we're going to work through in this video. Now, this is a circuit we actually had in an earlier one, and I put some ammeters here and voltmeters and bits and bobs. But basically, R1 is this, R2 is this, A1 is the amperage going through this leg, and A2 is the amperage going through this leg. V1 is the voltage drop over this resistor, and V2 is the voltage drop over this resistor, and the total is what they would be if we put them up here. So I don't want to mess the diagram up with putting too many things in it. So we're going to be looking at this one down here. We're going to be using Ohm's law and we're going to be using these facts here. So pause the video just a minute. Well, I'll pause the video while I just wipe this down and I'll see you in a minute. Right, let's have a work through the maths of this one then. Here we've got our circuit with a 10 ohm resistor and a 20 ohm resistor, and what we're going to do is work around it just using Ohm's law here. We're going to look at this top leg first and then the lower leg, and then we're going to work out the answer using the formula here, the reciprocal resistance formula, and we'll check that out and see if they make the same answer. So just starting off with that top leg up here, we've got a 10 ohm resistor, so our resistance is 10, voltage. In a parallel circuit, all the voltages are the same, so the voltage is 6. So in the top setup here, we have voltage 1 in this top leg here is 6. Resistance 1 is 10. So I1, the current in this top leg up here, which is the reading on an ammeter if it were there, I1 is equal to volts over resistance, 6 over 10, which is 0.6 amps. We're doing current there. Okay, now you may have seen that before. If you've seen one of the earlier videos, I worked through exactly this example on there. And so if you've seen that one before, you should be familiar with it. If not, doesn't matter, just apply the same thing yourself. Could you copy that kind of calculation there, but this time for the bottom leg? So pause the video and have a go at that now, please. Right, for the bottom leg we should have this. V2 is still 6, voltage is the same all the way round. R2 is 20 ohms, which means that I2 is 6 over 20, which is 0.3 amps. Okay, so that's the current through this leg is 0.6 amps, the current through this leg is 0.3 amps. If you imagine two tributaries of a river, when they join together, the current up there will be 0.9 because the currents add up. So that means that the total current, I total, is 0.9. Okay, now we can put that back into Ohm's law and work out what the equivalent resistance would be if these two resistors were combined into one resistor there in the middle. Okay, so imagine that those are squished up together. We're going to use the total current if you put an ammeter here or here, which is 0.9. The volts, of course, volts are the same all the way around, so that's 6. And so could you put it into Ohm's law and work out the total resistance, what it would be if those two were squished into one? Okay, pause the video and do that now, please. Here we go. I total is 0.9, V total is 6 as ever, which means that R total, R is V over I, which is 6 divided by 0.9. Now if you're not happy with dividing by decimals and fractions and things, check out some of the Batty Boffin maths videos. Normally people think that dividing makes things get smaller. And normally people think that decimals make things get smaller, but in this case, because we're dividing by a decimal, it actually gets bigger, and the answer to that one is 6.6 recurring, and that's ohms. 6 2/3, 6.66666. Okay, so that is the answer if we work it out just with Ohm's law and these two things, but of course we can shortcut it by using this reciprocal law here, and I'm going to do that over this side of the board in red. So we're going to do R1 and R2 and find R total. So our formula is that R total equals R1 plus R2 when they're all made into fractions. Okay, I'm going to need to rub out the word parallel there, I think, and I'll rub out those two bits as well. Give me a bit more room. So in our particular case, 1 over R total is 1 over 10 plus 1 over 20. 10 ohms and 20 ohms for our two resistors. Okay, adding fractions. It's not 2 over 30. Please, not that. If you're not sure how to add fractions, more Batty Boffin videos tell you how to do that. If you do remember, it's the common denominator thing. You have to put them over the same bottom number. So I think I'll give you a chance to have a go at that. If you can't remember how to add fractions, don't worry about it. Just come back after the 10-second pause and I'll show you. Okay, pause the video and have a go. Right, it should look like this. We're going to call 1 over 10 2 over 20. 1 over 10 is the same as 2 over 20. And when we add 2 over 20, 2 20ths plus 1 20th, amazingly the answer is 3 20ths. They haven't turned into 40ths. 2 of these things plus 1 of these things makes 3 of the same things. So 1 over our number is 3 over 20. So what we can do then is just flip both of them upside down. Our total, instead of 3 over 20, is 20 over 3. 20 divided by 3. 20 divided by 3, 6.6 recurring. Ooh, fabulous. Now, if you need to calculate total resistances in a parallel circuit, you can either use this, the reciprocal law, so you're basically adding them up, but they all have to be reciprocals, that's posh word for 1 over something. Or if you're not happy doing that, then you can just apply Ohm's law for each section and find the currents, add all the currents together to get the total current, and then you can just do it that way. That way's slightly longer, but the maths is a bit easier if you're not happy with handling the fractions. So, hope that's okay with you there, and I'll see you next time, Batty fans.
Mwahaha! Mwahaha! Mwahaha!